Problem 2.9. An electronic semiconductor device generates 0.16 kilojoule per hour of heat. To keep the surface temperature at the upper safe limit of 75 degrees Celsius, it is desired that the generated heat should be dissipated to the surrounding environment, which is at 30 degrees Celsius. The task is accomplished by attaching aluminum fins 0.5 mm square and 10 mm to the surface. Work out the number of fins. If thermal conductivity is 690 kilojoule per hour per meter per degree Celsius and heat transfer coefficient is 45 kilojoule per hour per meter square degree Celsius. Neglect the heat loss from the tip of the fin. So in order to solve this problem, let us first draw the schematic of this problem. So as you can see here, the diagram represents a semiconductor surface. Let this surface is at temperature Ts. In order to dissipate heat from this surface, some fins are provided, and as it is mentioned in the problem, the cross section of the fins are square shape. Let's say the length of the fin protruded from the base surface is L, its width is B, and thickness is delta. Let's say thermal conductivity of the material of the fin is K. This fin is exposed to the environment at temperature T infinity and convective heat transfer coefficient H. So this is the required schematic of this problem. This diagram represents semiconductor device provided with fins. After drawing the schematic, let us enlist all the given things. So as it is mentioned in the problem, the surface generates 0.16 kilojoule per hour of heat. So this will be the total heat which is to be dissipated from the surface. So Q total or Q heat dissipated will be 0.16 kilojoule per hour. The surface temperature must be maintained at 75 degrees Celsius. So Ts is equal to 75 degrees Celsius. The entire setup, that is semiconductor device plus fin, is exposed to the environment at 30 degrees Celsius. The cross-sectional area of the aluminum fins provided is of square shape. So its cross-sectional area will be B by delta 0.5 by 0.5 mm square. And length of the fin protruded from the base surface is 10 mm, that is 0.01 meter. Thermal conductivity of the fin material is given as 690 kilojoule per hour per meter degree Celsius, and convective heat transfer coefficient of the surrounding fluid is 45 kilojoule per hour per meter square degree Celsius. These fins are made up of aluminium. Now, after enlisting all the given parameters, let us make some assumptions for the facilitation of solution to get the solution of this problem. So assumption number one dimensional steady state heat transfer Assumption number 2, no heat generation within the fin itself. So Qg will be 0. Assumption number 3, no thermal contact resistance between the base surface and fin root surface. And as a result of this assumption, temperature at the root of the fin will be equal to temperature of the base surface. Assumption number 4, homogeneous and isotropic material of the fin, that is K value will be constant everywhere. Assumption number 5, uniform fluid properties. So H value will be constant everywhere for the surrounded fluid. And last assumption, insulated tip fin. Whatever fins are provided over the semiconductor device, they are not going to, they are supposed to be insulated at their end or tip. Then let us enlist what is to be found out. So from the problem statement, we are supposed to find out number of fins. So let us solve this problem. So in order to dissipate the heat from the semiconductor device, aluminum fins are attached. So each of the aluminum fin will dissipate heat, and that fin is assumed as insulated tip fin. So let's say let Q fin be the rate of heat transfer from individual aluminum insulated tip fin, and we are supposed to dissipate total Q amount of heat. So in order to provide this total amount of heat, in order to dissipate this total amount of heat from the semiconductor device, Q total will be equal to number of fins into heat dissipated from one insulated tip fin. So from this equation 1, I can calculate the number of fins, provided I am able to calculate heat dissipated from single fin, that is insulated tip fin. Okay, so let us calculate this Q fin first. So we know for insulated tip fin, rate of heat transfer. So this Q fin formula I can get from heat transfer data book. And that formula is given by, for insulated tip fin, as HPKAC into Ts minus T infinity over 10 of hyperbolic ml. Let's say this is equation number 3. Now in this equation, I know the value of H and K, Ts and T infinity, and value of L. Rest of the parameter I am supposed to calculate. So for square fin, perimeter P will be twice into B plus delta, twice into 0.5 plus 0.5 mm. So the perimeter will be 2 mm. That is 0.02 meter actually. Or 2 into 10 to power minus 3 meter. Similarly, for square fin, area of cross section will be width into thickness, that is 0.5 into 0.5 mm square. So it will be 0.25 into 10 to power minus 6 meter square. And the value of m, that is fin constant, is hp over k ac and square root. Value of h is 45. We can check. Value of h is 45, k is 690. Perimeter is 2 into 10 to power minus 3 over the value of k is 290 and cross sectional area is 0.25 into 10 to power minus 6. Entire term will be under square root. So from here the value of m will come out. Let me check, it is 290 or 690. Sorry, it is 690. The thermal conductivity is 690. So after calculating, the value of m will be 22.84 per meter. So after calculating P, AC and m from equation 1, sorry, not equation 1, equation 3, I can calculate the value of heat dissipated from insulated tip fin. So H value is 25, P value is 10 to power minus 3, K value is 690 and cross sectional value is 0.25 into 10 to power minus 6. This is square root of HPKAC, TS 75 and T infinity is 30 and 10 of hyperbolic. M value is 22.84 and value of L is 10 mm, that is 0.01 meter. So Q fin will be 39.77 into 10 to power minus 3 kilojoule per hour per fin. So this much will be the heat dissipated by the single fin with insulated tip. So now from equation 1, equation 2, I can find out number of fin as 0.16 kilojoule per hour. This is the total heat to be dissipated divided by heat dissipated from one fin, kilojoule per hour per fin. So after calculation, it will give me 4.02. So fin number cannot be fractional. The number of fins will be 4. So total number of fins provided over the semiconductor device to keep its surface temperature at 75 degrees Celsius are 4. 4 pins of square cross section can be provided. So this way you can solve this numerical.